Alrighty folks, welcome back. So here we're going to talk about a second example of solving an equation using elimination. So in this case we're looking at B, the highlighted one in the middle here, and we can see that as is, we're not going to eliminate anything. Right? If I add them together, I'll get 15x plus 6y, so I'll still have x and y. Even if I subtract them, I'll still have 5x plus 2y. Again, both variables still there. So I do need to change one of the equations. Now, it doesn't matter which one you change. And so just for the heck of it, I'm actually going to change the top one because I think that's not the one that most people would do, and just to show that it works. And so what I can do is, again, I like to number my equations. So I'm going to number this one, equation 1, equation 2. I'm going to take equation 1, I'm going to multiply it by 1/2. Alrighty, so if I do this, I'm going to have 10 times 1/2 will be 5x. And this one, 4y times 1/2 will be 2y. That's equal to -4. Oops. Now I'm not touching the second one at all, so I'm going to leave it like so. So I just copy that. 2y is equal to 10. That's a y. Okay, so now, let me clean this up. Now we can see, okay, well, which one do I want to eliminate? X or y? Well, actually, it turns out that in this case, both of them are going to eliminate no matter which one I pick. So if I want to eliminate x, well, they're the same sign, plus 5 and plus 5, so I'm going to subtract them. I would do the same thing if I want to eliminate y, because they're both positive 2y. So I'm going to subtract the bottom equation from the first one. So let's see, 5x minus 5x will be 0. 2y minus 2y is also 0. And then -4 minus 10 is equal to -14. So we end up with this sentence, or this statement. -14 is equal to 0. At least in the videos, we haven't come across this in a system of equations yet, but we do know what this means if I was just solving a regular equation. This is a nonsense answer, right? No value of x or y. No x or y will make this happen. We'll make this true. Right? Today, 0 is not equal to -14, and it won't be true tomorrow, no matter what x and y are. And so this actually has no solution. Right? So once you get to this, and this is, again, this is a case for a system or just a regular one variable equation, when you get to this nonsense answer or nonsense statement, it means that there is no solution. But I do want to take a second here in this video to talk about what this means visually or graphically. Right? And so remember, when we graphed this one, and I'm not going to graph the lines here. Actually, maybe we'll do it with Desmos. When we solved system A, we found the solution x equals -1 and y equals 6. Remember from the last video. What this means is that when I graph the two equations, this is where they're going to cross, and we can see that with Desmos. So actually, I am going to graph it on Desmos, so stand by for just a second here, please. Alrighty, so, sorry about that. So here's this is system A that I've drawn so far, right? We can see these two equations right here. Now, when I graph them, and we can see the solution x equals -1, y equals 6 is exactly where they cross. But what does it mean if there's no solution? Well, if by definition the solution to a system is where the graphs of the equations in the system cross, no solution must mean that there is no point where they cross. In other words, they would be parallel. And we can actually see that here. Well, strictly speaking, parallel is we're going to save that when it's two lines like we have here. These are two linear equations. If they weren't lines, then I guess we wouldn't say that they're parallel. But yeah, they're not going to cross. And we can see that here when I graph them. And we could also see, we could all test that by saying, okay, if I was to graph these, I could get them into slope-intercept form. And I can see that they would have the same slope, but different y-intercepts. Right? One has a y-intercept of -2, and one has a y-intercept of 5. And since their slopes are the same, they're actually never going to run into each other. And so I just wanted to use this video to, 1, show you what it looks like when there's no solution, and 2, be able to visualize that as well in the graph. So So thanks for watching, folks, and I'll see you in the third and final video of these elimination problems.